Data structures is a section within your software development section of the FE exam review. It's not given a whole lot of focus within the manual, but it's a very important topic if you're really creating higher level software that requires the use of a lot of data. And data analytics is becoming a very useful tool in the real world now, and knowing and understanding how to create and manipulate data structures is key to that. Starting off simple, you have your data types. These 6 here are your main ones that you'll find in a lot of your languages. Down at the bottom you see strings. They're not always supported. Others may not always be supported. Booleans aren't supported in C either. So um, in a lower level languages you typically don't get the functionality of all of it, but you can get a similar use. So for strings in C, you just make an array of characters. And since I mentioned arrays are probably your most powerful data type. In a low-level language, you can actually use an array to create an entire database if you really want to. If you are really good and you know how to manipulate an array just right, then an array can be a very powerful tool. You have these other data types that are really higher level, typically not going to be used in most sections. So you have your trees, your hash. A tree is exactly what it sounds like. It's a sort of array structure that basically says, hey, I want this data point, and then from that I want these children data points, and so on and so on, like a family tree. You can do down, up, middle, out. People do different stuff, but hashes, they're similar to trees. They work differently, but have a similar effect. Pointers, they're just really a link. So if you want to link to another point in your program or in another program or another database or another file, anything like that, you can use a pointer. That's what it refers to. Objects are a tool that gets used in a lot of higher level languages very commonly, like especially Java. Java is called an object-oriented language. Um, so if you really want to learn about Java, you need to know objects. And objects really feel like they're kind of a function that it refers to a lot of data that is exclusive to that function, and it gets kind of complicated. But if you really want to learn more about objects, you can look up Java, and it's one of the first things you have to learning Java. Dates, times, diagnostics, those higher level languages too, they sometimes will have built-in ways to reference a current time or current date or your computer's IP or host name or something like that. And error signals are special. They kind of are a data type and kind of not. It depends on your language and how it's used, but it's really just kind of a storage spot that holds what errors have been brought up by your code. So you have your relational data models. This is really how you relate your data. There are other ways than these two, but these are going to be your two most common. You have your hierarchical structure that really works at a top-down approach, where you have data, and then that piece of data has children data associated to it, and those children have children, and so on. And it works so that the lowest level can be traced back up to a single parent, and you know that model has to have these parents, or that piece of data has to have these other pieces of data associated with it, which can be good if that's what you're going for when that piece of data is selected. Link structures work slightly differently, where it really just you can move around and go backwards and forwards in data in multiple different directions, and there's no clear parent or child. It's saying, hey, from here, this piece of data is related to this piece of data, and you can create loops and such where it loops around and different functions manipulate different ones. You've probably used this in Excel if you've ever said equal to this cell and then made that cell equal to another cell. You've created a link structure. Your databases. Of course, like I said before, you can use arrays or different things. Database doesn't have to be a full software on its own, but you in the real world, you're going to have a database software that you're going to have to learn to manipulate. SQL Server and Oracle are your two main ones. Access is kind of going away. It's still fighting on, but Oracle and SQL are going to be the main ones you work with. Under this, I mentioned CSV files. Those are basic, similar to Excel, but when you pull them up, it uses commas instead of columns, and then new lines instead of rows. Very simple, plain text. It doesn't take up a lot of data to store a CSV file and can be referenced easily by a lot of languages. But environments, full database softwares are going to be your most useful way to manipulate and store your data. Queries. Queries are specific ways to find data within a database. And if you've built your own database using an array or a CSV file or something like that, your query is going to have to be some code out of whatever language you feel like using to create and manage your database. For Oracle and SQL, especially SQL, that's the one I'm a little more familiar with. It has its own scripting language, SQL script, and Oracle, I think, uses almost all the same syntax, so it's an easy transition between the two. And if you want to learn about queries more, this website here, w3schools.com, this has a great SQL tutorial that can get you really familiar with how to take a database table and how to select from it and all these different types of syntax and everything you can do with a database. Anything you really ever want to do. This website's also really great if you ever want to get into any other web development. It's a great way to learn it. And on that note, I will end this. Thank you. Bye.